Hello! This video was supposed to be the new build Spectrum episode, but I thought I'd sneak in a cheeky little one before that. As some of you may know, I'm putting together a number of machines with the help of a bunch of my friends and supporters to auction them off to raise money for the befriending scheme, a project that will end with me doing a 12-hour live stream with super special guests on the 16th of September when all of the auctions finish. Currently we have the ZX Metrum with a Harlequin 128K as the first machine. There will also be a completely new build original ZX Spectrum 48K, another OG ZX Spectrum, and yet another rubber key Spectrum with a different variation of the Harlequin 128K inside. Oh, and maybe an Amstrad CPC 464, because why not? As I mentioned at the top, the intention was to record making one of the new build Spectrums next, but I thought it might be a good idea to go off on a side quest and build this Byte Delight ZX Diag cart, kindly donated to the cause by Rudy of Rudy's Retro Intel. Rudy recently made a video comparing this cart to some of the other methods of running diagnostics on ZX Spectrums, and this one came out a clear favourite. I also recently bought one for myself, but haven't yet got around to making my own one. I thought I would put the one destined for the charity auction together first, so I can give it a really good thorough testing before it gets sent out to one of the lucky auction winners. And I have a broken ZX Spectrum here to try it out on. This one shouldn't take too long. Let's get soldering. Right, there don't appear to be any copyright notices on this set of instructions, I don't think. So I'm going to be showing these ones on camera, and to hell with the consequences. I've got some stickers from Rudy here that came with it, and I think I slipped in, here's the main PCB and Rudy's card. I'll leave that there. This all looks like it is how to set it up once it's built. So we're not interested in any of that yet. No features and things. There's a schematic. Oh, and there's a couple of QR codes. So you can, I'll put them separate so you can. Needed to assemble the kit: solder wire, soldering iron, preferably a desoldering pump and or solder wick, side cutters to cut the legs of parts, coffee or tea. I don't drink hot drinks. I know, I'm weird. I don't like cheese either. No, you're weird. And a beer for when you're finished, that I can do. These SMD parts have already been soldered on with the DIY kit. So there are, oh, black PCB again. Some good luck focusing, everybody. There's a few capacitors around here. There's a chip there, and there's some transistors strewn across here. But there is, I mean, I can zoom you in if you like, but you're not going to be able to see them. Oh, maybe. Sort of, there's just black on black. But I don't like black PCBs anymore. They used to be really sexy. Oh, I've got a serial number. Is that a 9G7? Or is that a 797? Or that might be 997, but I don't know. Maybe Ben's a doctor. Those are the parts that we don't need to worry about. I have two packets of components here. We've got chips, sockets, edge connector, and a load of bags here. And it looks like, yeah, these steps show the most logical, easy sequence to assemble. This is typical of Ben. The Harlequin kit was just fantastic. I know I had a couple of complaints about, I'm just an old man that moans, so don't take it to heart. But this method of bagging each individual component is, look at that, makes the job so easy. Neil from LLK Media for the, let's have a quick look at that. Yeah, Neil sent me this bag of components, and he's done pretty much the same. Yeah, Max 128, this is the Max 128 board. He's taken the bill of materials and he's gone through and he's bagged up all of the components for me so that I can have a similar experience. I won't have the step-by-step instructions. Also, I've been told by Julian that the FPGA on here, this Altera Max, is not programmed. So I need to learn how to do that. Thanks, Julian. Never done that before. Right, anyway, let's get on with it. So we have the bags are numbered in order. And obviously I'm going to do local. Oh, this is a 3D printed part. That's really nice. But that is to go underneath when this plugs into the back of the Spectrum. this clips, oh, it stretches onto there and sits on the back there, and that just holds it at the right height behind the spectrum. Ingenious solution, which is really handy because there will be occasions where I'll be probing around on here, and we'll come to that later because Rudy came up with a really nice little mod. But you can always go and watch his video and you'll see it there. So let's quickly just give this a wash. Yeah. Oh well, I might rub my serial number off here, but I've got a record of it. Oh no, it survived the IPA. We'll have to do this edge connector as well because we're soldering to that. So the diodes first. Is that he's pre-bent these? These are all pre-bent. That is beyond excellent service. Right, so we have D1, predictably. Let's warm up the soldering iron, grab some solder. I use, as somebody asked, what type of solder I use. I use Loctite multi-core 0.7mm, and I buy mine from CPC. It wasn't very expensive when I bought this one. Now it is. Sorry. I found D2 to D3, D4, D5, D1. And the black stripe is on the left. I'm going to use this to hold the components in place this time because, well, I got in a bit of a mess last time. I'm not going to do a fancy montage thing this time. This is just going to be a raw build video with just a top down and that camera. If the last video that I made, what we got here, resistors, the Harlequin build, I could have built that in, you know, I don't know, a couple of hours, I suppose, of work if I wasn't filming. It took me a couple of days, 2 and a bit days with filming because it just adds so much time to everything. Some R's there. R1 is here. R1, R5 to R12. Oh, having these pre-bent is lovely. R5 to R12. So R5, R6, R7. Oh, wait a minute. Right, so I'm going to leave. That's going to make things a bit more awkward. That's fine though, we can do awkward. Let's get this one soldered in because it's flat. Come on, heat up. Right, so the thing I want to do, and this is R5 to R12, is it also the other ones as well? No, R5 to R12 and R24. So I can do R24, and then I'm going to leave these for now until I've done all of the other flat components. And it's this very clever little mod that Rudy, I think he came up with it, to stand the resistors up so that you can hook a probe lead on so that you're with your oscilloscope. So just be super handy because yeah, all of these ones are data and all of these ones are M1, NMI, chip select, IRQ, MREQ, read, write, and reset. And being able to, and that side is the diode side, so you want to be on this side of to get a clean signal because it's going through the resistor so that the diode doesn't get burnt out by the signal, to give it the correct voltage. So on this side I'll stand them up so that I'll show you by temporarily putting one in. So something like that. Oh, like that. Get it? You'll see. So I'm going to rebag those because those are all these ones. Look, it's already getting complicated. This was only going to take me 5 minutes. I do like to make things complicated. Right, so we've got R4, which is needs to be not one of these. I don't think it is. It's down here. It's not, you know, that it really is bending the leads before putting them in the kits is way above and beyond good customer service. You have a bit of a reputation, Mr. Fiestig, and it's a good one. Right, let's go straight to this bag. R3, 21, 22, 23, 25. That's that bag done. Now we've got LEDs, so I can go back to these two bags here because things are sticking up now. Right, so we've got done R1, R5 to R12. Same again, but for all of these ones. Lush. It says to do the sockets next, and then the LEDs. Okay, we can do that. I'm doing these one at a time because I've learned my lesson with the last ones not to abuse the way that they the pins can slide out. So let's one at a time. Right, apart from a couple of small accidents, and one socket that didn't go in straight, but I ran the hot air over it and straightened it up, and they're all nice and flat now. It's all looking good. All of the sockets are in. Instructions then say go from sockets to LEDs, and there is a board layout, and helpfully shows you the polarity of the LEDs, which is the anode and cathode. And I can never remember which is which. The positive is the long one, and the negative is the short one. And where they've got to go, these ones are going in here. The square hole, the square via, is the negative, and it shows you quite clearly on here that the red ones are the positive, and the black ones are the negative. So these will be nice and easy. Grand. Right, 9. Bunch of capacitors. Right, the last thing, all of the bags are done. Capacitors, transistors, pin headers and jumpers, switches, and then the edge connector, which goes on here like this. And I need to bend these carefully, a little bit at a time, and evenly. we've got mechanical force holding it. Ta-da! Right, I've got it attached to my working issue 4S. This needs a recap, but it is working, and I've gone through all the settings on the board that I need. This switch here, right, yeah, so we slide it to the left, and then when I switch it on, you'll see the LEDs count down. You see on the screen it's running the diagnostic software. The lights up here are doing what they're supposed to, and the lights that are down here are doing what they're supposed to. It's showing that the voltage levels are present. The -5 and +9 look dimmer than the +5 and the +12, but I'm not sure if that's a problem or not. Oh look, it's doing some more tests. So if I switch this into the right hand position, then these just show the data activity on the data bus on the edge connector. If I put this J1 into the top position, which is pins 2 and 3, then the spectrum will just boot as normal. Now if it's got a dodgy M1 line, this second J2 in pin 2 and 3 position will use the M1 of the spectrum. So if I put this back into diagnostic mode, so if this had a bad Z80 CPU, this wouldn't work, but it does. And I'm pretty sure I've got some bad Z80 CPUs, well, bad M1 line Z80 CPUs, but this will be really handy to test this. So because the next thing I want to do is attach this to a broken spectrum. Let's see. Oh yeah, we're missing 5 and 12 volts, but the diagnostics was running. That's interesting actually. I am going to connect this up. Oh, it's not got a composite mod. Right, so composite mod done. Beautiful issue 2 board, really clean. And when I switch it on normally, this isn't the way I'd normally diagnose a spectrum. It's kind of trying to start. I think this is probably just bad caps. So with this in, we've got a bad RAM chip. Yeah. So we have got a bad RAM chip. Excellent. Well, this works really nice. There's 2 things that make this really cool. One is that you can immediately see if there's any voltages missing. Normally I would have to check that by checking each chip's voltage rail and making sure that they were all present there. But I can immediately, straight away, I can switch that on and see that -5 and 12 are not as bright as they possibly, in fact they're missing on there. And the other thing is it almost straight away shows me that there's a bad RAM there. I like this. This is a very cool thing. So this will need a recap. Once it's recapped, I'll test it again and then make sure that it really is that RAM chip that's failed. This will be included in the auction on the 16th of September. If you'd like to make a donation to the charity, go and have a look at the Just Giving page. And thank you for all the people that have donated so far. I'm blown away. Special mention to Rob Green for 2 stunning donations. And I really didn't mind that you you typed in the what was it? Keep up the great Lee. I will keep up the great Lee. Thank you everybody for watching, and I'll see you in the next one. Goodbye. Tiny little addendum at the end of this video. I recapped this Spectrum. This is just for the curious amongst you, which I counted as myself as well. I recapped this Spectrum. I suspected there wasn't actually anything wrong with it. I tested TR4 before I powered it on because that was the most likely one to go with my multimeter, and that was showing some abnormal signals, some abnormal forward voltage. So I popped that out and put it in my component tester. It thinks it's a resistor. Well, it thinks it's 2 resistors. I replaced TR4 with a new transistor and tested it TR5 again because that was showing some abnormalities with TR4 faulty. Once TR4 was not faulty, TR5 then looked good. So I then plugged it in and switched it on. And well, there's no lights indicating a faulty RAM on the board. All of the voltages are now lit up as they should be, and we've got normal activity, and the tests do pass. It's a horrible yellowy green colour because there's one of these trim pots needs adjusting. I wonder if it's just scratchy. No. One of these variable resistors here that I will do with my oscilloscope connected up to the composite output just to get the best possible picture. But yeah, I just wanted to show you that the cartridge works really well, and it just illustrates that most Spectrums go faulty because the capacitors go bad, and it tends to be the ones that are close to this heatsink that dry out really badly. I'm not an advocate of changing capacitors without good cause. Most capacitors from back in the 80s that are a good brand in good design machines, things like the Commodore 64 spring to mind, they don't need changing, not unless they're faulty. But Spectrums, yeah, might as well change them. And I probably didn't need to change all of them. It's not a bad idea to do it. I know some say that you only need to change the ones that are bad, but to the time it takes you to actually find out which ones are bad and which ones are good, you might as well just change them all. They're not that expensive. But there we go. This is a lovely little issue 2 Spectrum that's in full working order now, or it will be once I change one of these variable resistors. And this will go back to Paul Universal Retro Boss. A happy working machine for many years to come, I'm sure. Thanks for watching. I'll see you in the next one. Goodbye. Oh, we're recording.